Like addition and subtraction, multiplication can also be taught using place value, which means that students have to understand and think about the value of each digit and what it represents. As with all concepts, work with only numbers should not happen until after students have worked with manipulatives and pictures and truly understand what multiplication is and means. Take a look at these two problems and see if you can work them out by multiplying using place value. Remember that when we're multiplying with place value, it doesn't matter where we start. Pause the video, do the problems, and then let's see if your thinking aligns with my thinking. Remember that you could start with either the tens or the ones place, so you may have started with one and I may start with the other, and that's not a problem at all. I'm going to start with the 2 here, which actually means 2 tens or 20. I'm going to take that 2 tens times this 10. So if I take 2 tens times 10, that would be 20 tens or 200. Or I could be thinking 20 times 10 is 200. Now I'm also going to take that 2 tens times the 4. 2 tens times 4 would be 8 tens. Now I'm done with the 2, so I'm going to go over to the 3. 3 ones times 4 ones is 12. 3 times 10 is 30. And now I'm going to add those together to get my answer, which is 322. Now if you started with the ones, or if you started with the tens but did things in a different order than I did, you may have these numbers in a different arrangement, in a different order, but those numbers should all be there. If I move over to this problem, I'm going to start with the 4. I'm going to say that 4 is 4 tens times 300. Now 4 times 300 would be 1200, but it would actually be 1200 tens. 1200 tens. Now I'm going to take those 4 tens times the 6 tens. 4 times 60, or 6 tens, would be 240, but it would be 240 tens. Now I'm going to take those 4 tens times 2, which is 8 tens. Now I'm done with the 4, so I'm going to move to the 5. 5 times 2 is 10. 5 times 6 tens, or 60, is 300. And 5 times 3 hundreds would be 15 hundredths. So I would have all of these to add together. Now if you did this in a different order, these numbers may be arranged differently, but they should all be there. The numbers should be the same. So if I add these together, I have 16,290. The nice thing about this method is that when students are multiplying, they're thinking about the value of the number. So when they look at this number, it's 300 times 40, or 300 times 4 tens. They're always thinking about what that number means. It's not just a digit. Of course, if you look at this, there's a lot of writing here, but for many students, this is still easier than thinking about all those procedures in the problem itself. Lattice math is a nice method for some students when we move from place value to procedural, because for some students it helps them organize the problem. Lattice math is not really conceptual, it's just a procedure, but it helps students keep track of what they're doing. It helps them stay organized. Try this problem and see how you do. Pause the video, and then see when you're finished if your work agrees with mine. The nice thing about this is that, again, you can start anywhere. So I can take the 1 times the 2, and I can put that here. 4 times 2 is 8. 1 times 3 is 3. 4 times 3 is 12. Now I filled in my lattice, and all I have to do is add up my diagonals. 2, 12, 2, 0. What these diagonals represent are place value columns. These are the ones, these are the tens, these are the hundreds, and this would be the thousands if we had any. Now the problem, of course, is that I have 12 here in the tens place, and we know that I can't do that because 12 tens means I actually have 102 tens. So I'm going to move that 100 over to the hundreds column where it goes. That means that I don't have 2 anymore. Now I have 3, and that leaves me with just my 2 tens and my 2 ones. So my answer is 322. I have 2 ones, 2 tens after I grouped tens together to make another 100, and then 3 hundreds when I moved that 100 to the hundreds column. So here's my answer. How did you do? Multiplying with traditional methods can be very confusing. There's a lot to write, there's a lot to keep track of. So I don't really feel that it's necessary for students to use the place value language all of the time, but we do want them to understand what it is they're doing. So stop the video in just a minute and do these 2 problems in a traditional method. And as you're working, see if you can speak out loud to explain somewhat at least what you're doing. I'm going to start this problem in the traditional method. 3 times 4 is 12, that's a 10 and 2 ones. 3 times 1 is 3 plus 1 is 4, that's actually 4 tens. Now I'm done with the 3. Because I'm done with the 3, that also means I'm done with everything I've already used. So I'm going to get rid of this, otherwise that's going to be confusing. And because I'm done with the 3, I can put a 0 here because I'm not going to be multiplying times 1s anymore. Now I'm starting here with the tens. 2 times 4 is 8. It's actually 8 tens, which makes sense because the 0's already there. 2 times 1 is 2, and that's actually 2 hundreds because it's 2 tens times 10. So it's 2 hundreds, which makes sense because that 2 is in the hundreds place. Now I can add these together, and I get 322. With this problem, I'm going to start with my ones place. 5 times 2 is 10. I have a group of 10, so I put that above with the tens. 5 times 6 is 30 plus 1 is 31, because that would be 31 tens. And 31 tens means I have 3 hundreds and 1 10. So I'm putting that 3 with the hundreds where it belongs. 5 times 3 is 15 plus 3 is 18 hundreds. And again, if you look at it, the 18 is in the hundreds place, which makes sense. I'm done with the 5, so I want to get rid of these so they're not confusing. I'm not multiplying times 1s anymore. Now I'm going to start with the tens. 4 times 2 is 8. It's actually 4 tens, so that's 80, which makes sense. 4 times 6 is 24. It would be 24 tens, which means this 2 is really hundreds, so I have to put it with the hundreds. 4 times 3 is 12, plus 2 is 14. That would mean 14 thousands because I'm multiplying this times tens. So I'm taking hundreds times tens, which would mean thousands. So if I add these together, I get 16,290. So you can see that this way really is more efficient. There's less writing. But it's also quite confusing because you're thinking a lot about those values of the numbers. So what does it mean to take hundreds times tens and end up with thousands? What does it mean to take tens times ones and end up with tens? That kind of thinking is hard for kids, but it's also very good for them. So when we get to the procedures where they're just doing rules, that's really okay, but every once in a while we need to have them back up and think about the value of the number. And another thing we can do is just to have them look at the beginning of that and make an estimate. If I was going to take 300 times 40, what would that mean? It would mean that I'm going to take 4 tens times 300, which would be 1,200 tens. So my answer has to be sort of in the ballpark of this. Of course, it will be very different, but if my answer were 1,629, or for some reason I came up with 162, I could look at that and say, whoa, I am way off. It at least gives students that ballpark figure. The idea here is that even when students are using procedures, we want them to be thinking about the value of the numbers. 300, thousands, ones, tens. It needs to be logical. We want them to develop rational number sense. And we can do that with the language we use and by having students back up and explain their thinking occasionally.